All right, welcome back. As promised, here is the second video of graphing sine and cosine. We're going to do 5 examples. Hopefully it shouldn't take us too long, but we're going to go through kind of piece by piece here. The first one being the simple one, 2 sine of x, and we're just going to go ahead and graph. So what I want to do is I only want to graph one full period of the function. So I want to make it look like this, just one full curve. And eventually we'll get to the point where we can do more than one. So what we need to do is we need to figure out A, B, C, and D. We know A is 2, B is 1, C is 0, and D is 0. A is the number in front of sine, B is the number in front of the x, C is if there's any plus or minus by the x, and D is if there's any plus or minus on the outside. So from this, we know that this is my amplitude. And from the B, we know my period, which is, you got to remember, I'm going to put this up here, period equals 2 pi over B for both sine and cosine. Period is 2 pi over B. B is 1, so my period is 2 pi. So what I kind of want to do is I want to show you how my method works. And I know since there's no phase shift, no vertical shift, none of that, I'm going to center everything on the x-axis here. So this is my x-axis, obviously. This is my y-axis. My amplitude is 2, so I need to go up to 2 and down to -2 from my center line. You can put in the 1s if you want. My period is 2 pi with no phase shift, which means I'm going to start at 0 and end 2 pi away. Now, if you remember, we start at 0 or start somewhere, we add the period, or we finish at the period. We go to half the period. Half of 2 pi is pi. And we go to the quarter of the period. The quarter of the period here is pi halves, and the other quarter is 3 pi halves. So that right there is probably one of the hardest things that you guys will end up having to do, is to graph or to create your axes. The x and the y, axes, plural for axis. Now, I'm going to do this in my method, so kind of follow along here. I'll do the second way as well. I'm going to say, okay, this is a sine function. I know normally sine starts at 0, 0. Since there's no phase shift and no vertical shift, I start at 0, 0. Now, if you follow along on my method, I said I start at 0, 0, and I have to end one full period away at the same spot. And then I also know for sine, sine goes up, middle, down, middle. So that means sine is going to cross at the halfway. It's going to be at amplitude at the quarter and the other amplitude at the other corner. From that, I'm going to do my best to make a solid, smooth curve like so. And there we have sine of x, or 2 sine of x actually. If I was to do this in the other method, you'll notice that this comes out exactly the same. If I get rid of my extra dots here. If I said, oh, okay, my other method said take the thing inside the parentheses. In this case, it's just x equals 0, pi halves, pi, 3 pi halves, and 2 pi. Well, since there's nothing to do, I actually just get to go straight to my table, and I go 0, pi halves, pi, 3 pi halves, and 2 pi. And I just plug those numbers in. Sine of 0 is 0, times 2 is 0. Sine of pi halves is 1, times 2 is 1. Sine of pi is 0 times 2 is 0. Sine of 3 pi halves is -1 times 2 is -2. And continue that. Sine of 2 pi is 0 times 2 is 0. And again, I get those points again. I get to 0, 0, pi halves, comma 2, pi, comma 0, 3 pi halves, comma -2, and 2 pi halves, or 2 pi, comma 0. And you can continue this pattern in either direction for as long as you want. Right now, we're just doing one full period with correct arrows coming off the ends. Okay, let's try another one here. Half sine of half x. These should look familiar. They're the ones that we did earlier. Oops. Okay, I just set up my axes. I don't do anything just yet. I want to figure some stuff out first. So A is half, or 0.5. B is also a half. And again, C is 0 and D is 0. So this tells me my amplitude is 1/2, which means I need to go, let's just go up to 1 so we can put in the 1/2 so we kind of looks a little bit different here. We'll go down to -1, and we'll put in the 1/2. My period is 2 pi over 0.5, which is 4 pi. And let's kind of try to do my method. Again, it's just faster than finding all 5 points. Now, sine, again, there's no horizontal shift. There's no phase shift. So I'm going to start at 0. I need to go one full period away, and one full period is 4 pi. Half of that, notice it's just about breaking things in half. Half of that is 2 pi. Half of that is 1 pi. And the one in the middle has to be 3 pi. And then I just go through that same method. I go, okay, sine normally starts at 0, 0. There's no horizontal shift, no vertical shift, so I start at 0, 0. I end 4 pi away. My halfway is in the middle again. I go up in the middle there and down to the middle there. And I get some nice curves going on. Okay. What I want to kind of do for this particular problem, though, is what if this was negative 0.5 sine of 0.5x? Because we can do this. We can just kind of change this a little bit. Nothing changes for A, B, C, and D. Only case is now my amplitude is technically negative. But none of my things change over here. But since it's now negative, instead of going up, I'm going to go down instead. So I'm still going to start at 0, 0. I'm still going to finish at 4 pi. I'm still going to be in the middle here. The difference now is instead of going up to half, I have to go down to -half, back to 0, and then up to +half. So this is how that negative changes the graph in general. Okay, moving forward. Cosine now. So cosine of x minus pi plus 2. So you notice now there's some vertical shifting going on and some horizontal shifting going on. So because I'm going up 2, my y-axis doesn't really need to be very visible. It needs to be down at the bottom. Okay, A, oops, I don't want green here, is 1. B is 1, C is pi, D is 2. So this is an up 2 units. This tells me phase shift is C over B. Oops, not B, we have a B. Pi over 1. So it's pi to the, because it's minus, so it's to the right. The B here tells me my period is 2 pi over 1. Well, that's just 2 pi. And my amplitude is 1. Now, here's what I have people do for this particular graph. Because we need to go up 2 units, you call that 2. What I do is I have people draw in a little dashed line that's not technically there, but it's a guide because I call this my new x-axis. Meaning everything is based off of this line, not my x-axis down below. Then my amplitude is 1, so I need to go up 1 and down 1 from 2. So my entire graph goes between 1 and 3 here. Okay, so here's the rest of it. I need to go pi to the right. So I'm going to say that little distance there is pi, which means that distance is pi, and that distance is pi. So that's 2 pi, and that's 3 pi. And if you want to, you can put on a 4 pi. We're not going to need it, though. 1 full period is 2 pi. Well, this distance between pi and 3 pi is 2 pi. Notice I've shifted to the right pi units, and I've gone 2 pi away. So this has now created my x and y axes and gives me enough information to graph. So let's change colors. And we're going to go ahead and do this. All right, so this is cosine on my axis. So be careful here. On my axis. Cosine, first of all, normally starts up. But the thing is, I need to shift to the right pi units. So I'm going to start right there. Now, cosine does this. From this starting point, it goes down, up, and stops at the same spot, 2 pi, or 1 full period away. Halfway between is the bottom of my valley. And then if we put our halfways in there, we get this. Now be careful when you draw this. This is not a V shape. There are no straight lines here. This is, to the best of your ability, a curved line. Oops, that was kind of ugly. And here's where I get a little bit kind of picky. Start it. First, I like pretty graphs. You need to know where the arrows go. The arrows do not continue up. If you remember the graph from before, that does not continue up. It's actually going to come back down for your arrows, and this is going to come back down for your arrow there. Okay, so there we have it, the graph of cosine of x minus pi plus 2. This is just 1 full period with obviously just a little bit extra stuff on the left and right. Okay, let's continue. I'm going to kind of speed up the process here a little bit. I'm going to, first of all, start off with saying things like A is 10, B is 2, C is pi, and D is 3. So notice we have all 4 versions here. So my amplitude is 10. My period is 2 pi over 2, which is pi. My phase shift is pi over C over B, so pi over 2. And it's a plus, so it's left. And this is down 3. So down 3 means I need a x-axis way up here somewhere. And left pi halves means I need a little bit on the left and the right of my y-axis. So I need to have at least a pi halves here. So this distance is now pi halves, so I'm going to use it again. Now, if you started counting, I need a period of pi. Well, let's go pi halves and plus pi halves. Oh, that is a distance of pi. So this right here is pi units away. Ooh, I did not think when I was making my graph. Let's kind of, that's fine. I'll explain what I'm talking about here. I need to get rid of that line because I need to come down a little bit. So I did something kind of as error here, not thinking as I was doing this. My amplitude is 10, and I need to start at -3. So I need to go up 10 and down 10 from -3. So I'm going to need to be able to see some numbers that I couldn't see with what I drew there. So if I start at -3, and that's where I put that little dashed line, that's my fake x-axis, my new x-axis, I need to go up, and this is not drawn to scale anymore, so this is up 10 from -3, and down 10 from -3, -13. And now I can actually do this graph. As soon as I've made my axes, I can do the graph. This is a sine function, so sine is going to start on my dashed line, left pi halves on the dashed line. It's going to finish 1 pi away, and the half is going to be also at the 0. And then I'm going to go up 10 and down 10 at each of the quarters, and we should have a very tall, hard to draw, skinny, oops, wow, that was ugly. So I'm not very good at this on the computer, obviously. I'm much better on a whiteboard or a piece of paper. And most of you guys will not be very good to begin with, but that's why we practice. Okay, I'm going to kind of leave it there with these 4 that we just did, and I really want us practicing a lot of these graphs. We're going to spend 2 days, obviously, at least 2 days on these 2 lessons, or on this lesson, 2 days on the next one, another extra day. Hopefully we'll get this down. All right, come to class prepared. I hope this kind of enlightened you on how to graph.